Well, welcome to day 2 of the 2025 AGTA American Gem Trade Association's Inspire Seminar Series, sponsored by the AGS, the American Gem Society. An historical review of lab-grown diamonds and their detection. With us this morning is Branko Deljanin. Branko is president and head gemologist at CGL, the Canadian Gem Lab, and Director of Gemmological Research Industries in Vancouver. He's a research gemologist with experience in advanced testing of diamonds and gemstones, an expert in identification of natural, treated, and synthetic diamonds and gems. Branko is an instructor in intermediate to advanced gemology programs offered in 20 countries on 4 continents. He's been a regular contributor to trade and gemmological magazines and has presented reports at several prestigious research and gemmological conferences, including the Mediterranean Gemmological and Jewelry Conference that he co-founded in 2015. His latest book on diamonds, natural, treated, and laboratory grown. You have that at the booth, I assume?
Yes.
All right, very good. Please join me in welcoming Branko Deljanin.
Thank you, Gary, and thank you for AGTA for inviting me back to talk. Much bigger room, more people. Less than Richard Hughes, of course. He's a great speaker and very funny speaker. I'm not so funny. I have a still big accent after 30 years living in New York and Vancouver, but I will try to do my best to give a good lecture overview how we came here, that 6 or 7 diamonds sold now in North America are synthetic diamond, and a little bit review. It's not strictly identification lecture, but who wants to stay to the end? Because we have now time for lunch. At the back, I like to do always practical. Even Gary doesn't know yet, but I have some stones on the back that you can come and see. I have some books at my booth, 54, and here you're welcome to buy or look at them. So I was busy traveling every year, 2-3 countries, new countries, teaching workshops and talking about this topic, identification of laboratory-grown diamonds. First, I like to put this slide because, of course, to compare historical sources of natural diamonds. And I was very, very happy that 2 months ago, I went to the first source, Golconda, visited, you will see a slide at the Krishna River, where all big diamonds coming from. And I know Gary studied some blue diamonds. They're famous from India. Then Brazil came in 18th century. I was there as well, in Diamantina and Coromandel. South Africa, I was in Kimberley Mine. African countries, I didn't visit all of them, but I'm trying. This is chronological order. I was in Russia in 2000, visiting Siberia and places who are growing diamonds. In 50s, become a number 1 sources now, with Botswana, maybe now number 1 took over Russia by value and volume. And number 3 is Canada, where I am. I moved there 2002 because of rough diamonds and because of becoming Vancouver center. My wife is specialist for rough diamonds. What's the problem? That most of these diamonds mines are closing now, or they are closed. There are no new mines coming up. And you will see a reason why. One reason is booming CVD production in India. That at the end I will talk about that. Of course, Australia is the number 4, used to be, not anymore, because they closed biggest diamond mine in the world, Argyle, with nice pink diamond. No time to talk about this today, but I talked 3-4 years ago about pink diamonds and provenance, how to source. This is my specialty. I studied them. Who wants to know more, please see me at the booth 54 about this topic. This is just one slide. I won't talk about each. I won't repeat everything, but people doesn't know that 52 first CVD came out before HPHT, what was 53, 54 in New Jersey. Of course, not gem quality. Gem quality came only in 2001, 2002. I was one of the first people to discover them with Thomas and Emanuel Fritsch. I studied Russian stones a lot in 90s and 2000, and this is companies I deal with for 3-4 years, ATC, Chatham, Gemesis, New Diamond Technology. All these companies are bold, are companies that I did research, I have samples, I teach. There are many, hundreds of companies in China, India, Russia, of course, and others that I don't mention by name, but I do have their stones. My goal is to present you some kind of overview in a periods, and each period is important from point of what color they produce and how we detect them. 2000, 2005, very early period. and actually I was responsible for the first synthetic diamond report in New York with the color and clarity technology for natural. Maybe I regret now because I didn't know it to be so big. 5 years after, GIA, IGI also start to do it in many labs. Not everybody, some labs don't do it. 2006, 2011, early period, they start to produce more colorless diamonds and bigger stones. Then you can call it interim period that where a lot of CVD diamonds came out, big sizes, over 5 carats. China became big, India as well. Of course, Russia was always there. Maybe Israel came out in 2015 with the Lu6 and other companies. This is what we call post-light box period. Why? Because 2018, the BIRS announced they're doing it. They changed the market. You will see later. And all of this follows by different instruments we're using to detect them. I don't know this exactly 70, but maybe 60, 70% of diamonds by number, not by value, are sold laboratory grown or synthetic. I like for synthetic or laboratory grown is the same thing to me. Things change, you will see now. So when I started, we definitely called them synthetic diamonds, and we issue reports synthetic diamonds, I remember, in 2000, 2001, 2002. They were mostly yellow, and they came out few browns and white in this early period, HPHT and CVD. This is CVD here. This is how it looks crystals. I've seen big one in India. They can really make big ones. And a lot of melasse. Why am I telling you this? Because it's very important. 2001, I was in South Korea, Iljin, and gentleman on the right, Gary Roskin, at that time was a JCK magazine author. He put a picture of me going through the bucket of the small mele diamonds, like this. They're making it, they're the third largest producer, Iljin, in the world. They have so many little rough 10-pointers, 20-pointers. Where these stones end up? Somewhere. So we discover later they also come to jewelry, but only 3 years after. So who knows what they did for 3-4 years, probably sold as natural. Anyway, this is one of the first, not first, but modified bars presses that basically Gemesis were using at that time. They closed many years ago, but this is a typical cell, how they grow diamonds from the more high temperature, 1,000, maybe 300 degrees approximately. This is cooler, and they grow in this cubic and octahedral direction. You'll see pictures later of the rough. This is one of the first Chatham created diamonds. On the back, I have a book for Tom Chatham, very nice book. They talk about history of this. He was in Russia, at that time, Soviet Union, growing diamonds and other Asian countries. So very interesting history, who wants to know more. So at that time, it was like this. We have this as grown. This means they didn't treat them. Colorless type 2A, but quite rare. Mostly blue, yellow, or orangey, and green. Basically, combination of the yellow and blue face up was green. This is without treatment, quite rare. Then, of course, we have treated colors. Could be more intense orangey yellow, more green, and this is very common pink HPHT grown diamond at that time, and then CVD later. Who wants to come on the back? Very easy to detect them with the fluorescence. They're strong orange, and the long UV, short UV, they're screaming, I'm treated. Now you have to say if it's treated synthetic or treated natural pinks, a little bit different fluorescence. I cannot talk about too much about this, but it's possible. This is very first press I've seen in Russia in 2000 in Novosibirsk, what is the center for growing diamonds at that time. In Moscow I went as well, of course. In my book, first book actually was 2004. Sherry Woodring, she was talking yesterday at AGA conference, and me worked together, and we did this first book, sold in 2,000 copies, sold out. Then I've seen my first cubic press in 1999 in Novatech Corporation in Utah, because they were doing also treatments of diamonds. US Synthetics did the same, maybe Suncrest company. They are quite expensive, big presses to grow diamonds, industrial quality, and also they can grow gem quality. This is me. He's standing on the Japanese researcher Hisao Kanda. To be tall as me, he had to stand up. This is a huge press, 30,000 tons, just used for experiments, for research in institute in Japan. I was there actually with Jim Shigley talking at that time about synthetic diamonds 2001, 2002. Gemesis creative was very easy at that time because they have a huge inclusions. In this case, not so easy when they're cloudy. Of course, we laser inscribed them at that time, and the fluorescing and the short UV a little bit stronger. Not so obvious as colorless and blue, but you could separate with the simple techniques. Why? Because they grow from seed in this direction, cubic and octahedral, very easy to separate, of course, when they're rough, but they're not always rough, they're faceted, and we need to look for these clues. From 2000 to 2005, 10, we can see these clues in fluorescence, in zoning. It was easy. And some charts from old charts from GAA was like that. Now, not anymore. Forget about this. Just telling you what to look for, what not to look for. It was easy to see big inclusions, I1, SA2. It was in that time important to say it's VVS2 or I2. Value was different. Now, all of them are VVS and VS. Doesn't matter anymore if it's this clarity grading has become less important, I can say, than 2000, 2005. Big inclusions, clouds, more tricky, but it's possible the flux clouds. So what we did with Dusan Simic, my colleague from New York, we did that time another book, 2007, also sold into 2,000 copies. I have some old copies in Portuguese and English. So we look at the pattern in the diamonds. This is 2 3-point diamonds, small diamonds, but under microscope, you can see strain or stress. We call it birefringence in gemology. Very different than stones that are made in laboratory or factories. They don't have a stress or strain. I like to call them baby-born, happy, stress-free diamonds. Not like me working in New York in the laboratory when Jewish customer wants to have everything same day, next day. I'm stressed, like natural person. This is more relaxed. I'm now more in Vancouver, nice nature. I'm more relaxed. This is me in Vancouver or somewhere else. At that time, we noticed that it was still valid. When you see long UV, almost none, maybe very weak or weak, and this is medium blue and phosphorescing 30 seconds, 1 minute. You're welcome to come and see. I have these stones. HPHT synthetic are easy to detect. CVD are complicated. But then, of course, we did some advanced testing at that time, still valid. You can see nickel lines in visible spectroscopy. You can see color zoning. You can do many things with the advanced spectroscopy. You can see proved why this is a orange fluorescence, strong orange, because of this band here, 637, NV center causing this. Very, very rare we can find these bands in natural pink diamonds, in Golconda, but fluorescence is not so strong. So these are always some exceptions to the rules. We do visibly find this single nitrogen band here, and this is very easy. Medium blue, phosphorescing, no problem. We don't need really advanced spectroscopy for HPHT most of the time. Sometimes we do. This is Yellowstones. What is important that single nitrogen is stronger than regular A aggregation. This is 2 nitrogen atoms come together. This is A. This is classic test. What is important for you to know? There is no single test, one instrument, one test, who can tell you 100% that is synthetic diamond. If somebody tells you different, they're lying to you. Even this test, based on this test only, this could be natural diamond of yellow, Canarian type, very rare, orange yellow, nice, intense. 1% of natural diamonds are this type. So doing just infrared, I can just know it's suspicious stone to be synthetic, but could be 1% natural. Okay. Next. So this is interesting from my book. We found one out of hundreds of thousands that's based on infrared spectra, looks very much natural because this A is quite high, even start to form the B aggregation. Why? Because they hit diamond to higher temperature, post-treated, and basically I like to do analogy with the family. Single guys are teenagers, they become 2 of them couples, and then they come 3 or 4 nitrogen together like a family. This is B, but when they divorce, they become 2 again, or 1. They're breaking basically, they can create these 4 nitrogen atoms B with the heat, but sometimes they can break and be a single nitrogen. So it's very important to know that we can form or destroy nitrogen, depends temperatures you're using and how you are doing that. So this is a problem that came out, it's still a valid problem. 2006, it was just it was CVD conference in Vancouver, and we announced this press release. In this ring, we found 1 or 2 stones that doesn't behave like natural yellow diamonds. Short UV was stronger than long UV, and you can see a picture. Hopefully, I asked for less light, but hopefully you can see how you see this cubic or square green under short UV in 2-point diamonds. So this is why we flagged this one stone test, and we found it's synthetic. That was one from maybe from Korea, maybe somewhere else, that was grown as a small melee yellows. So this summary is important at that time. It's still valid today, but much more complicated. We find, for you to know what we can do with standard instruments. Of course, metallic inclusions, what is rare, or little points you'll see later in CVD, can tell you this HPHT. But this is clouds, color zoning. Fluorescence is still very important. we can find in advanced spectroscopy elements of catalyst, nickel, or cobalt, or other impurities as single nitrogen. This is all your advanced spectroscopy, mostly for labs. But now, a company like Marjorie Labs, they're across me at Edge here, they're doing portable instruments. So people are buying more and more. Appraisers like most of you, or jewelers, are getting these portable instruments. They could be as cheap as $10,000 to $20,000. So how it looks, CVD? CVD very different than natural diamonds or HPHT because they're mostly flat. It could be rounded flat, could be square flat, could be this shape. Please notice here on the side, this is your amorphous carbon that did not crystallize into diamond. And sometimes we see this evidence on the edge of the diamond or inside the stone, like a little black spots. Not a proof if it's black spot, could be carbon spot in natural diamond and argyle, for example, but be suspicious. That's it, what I can tell you. And this is my first stones that travel around the world. Why? Because 2001, when I was in New York, I discovered the flat, the type 2A, and there doesn't behave like natural. And I travel everywhere with these stones, 10 stones, study with Thomas, Manuel Fritsch, Japanese labs. That time they were not very natural, not very great looking, brown. And they were type 1B, could be, 2B blue, or 2A with some sources, some nitrogen to be dark or light brown. When they treat them, and this is now very common, most diamonds now on the market are post-treated brown diamonds. How I know? Because I see a difference in fluorescence. When they're as grown brownish, weak orange fluorescence on the short UV, they change to weak greenish blue, bluish green, and sometimes you can see a little bit of phosphorescence. I have stones on the back, you're welcome to come. But new CVD could be the same weak, or medium, could be non. I collect new samples from India. I study now with Thomas Henschwagen. We didn't finish projects. We'll publish in Journal of Gemmology, some small article, hopefully. So we are looking into this. So blue are rare, but they could imitate very nicely argyle blue diamonds because they don't fluoresce. And it's not easy to separate with standard instruments, but very easy with advanced. The type 2A, they have silicon present. Natural diamonds don't have silicon. And this is, I told you before, very easy when it's pink, strong orange fluorescence. This is one of the first pictures from Apollo Diamond. At the time in Massachusetts, I couldn't go, unfortunately, to visit them, but they gave me the photo. Then with Thomas, we studied them. We found a lot of hydrogen very far in infrared. And this is the first time we found this 737 line. Of course, other companies, GA, and they also published a few months later papers. We published it basically Jewelry News Asia in English and Chinese in 2003. 2002, I was in Boston and Massachusetts to talk about this Material Research Science Conference. Sometimes I cannot wait 6 months, 1 year to publish in major magazines. So many people doesn't know about this, but we did CVD detection first. This is from the book Diamonds, how they look before and after treatment, CVD crystal. And I wasn't lazy because I was in Japan. I know nice, also CGL, but Central Gem Lab. We did this before and after treatment spectra. Why? To see the difference in fluorescence and spectroscopy. Don't pay attention to all these lines. This looks like a Thomas graphs, a lot of peaks, but you can see here there is no entry center, what is causing blue fluorescence in natural diamond. It's mean all these stones will be flagged. Here also should be flagged because entry center is super, super small, but showing up. These nitrogen atoms put together with the heat and create these 3 nitrogen atoms center and huge band here. That's why fluorescence is greenish blue after treatment of CVD, not orange anymore. This is just the science behind that. So interim period, what's happening in 2012, 2017? I was following all this and some of my speakers. I have a lot of free online webinars under practical webinars, brankogems.com, nothing to pay. Just listen to this guy from India from 5 years ago talking. I think some of them moderated by, not by Gay Roskin, by Robert Bates. Robert Bates was moderating very good webinars. Some of them are fee-based when it's a kind of workshop style. So this is the stones, at that time, more CVD, more colorless. Basically, we can every color. Still, trade was not so much worried. It was worried, but not so many colorless but they were coming, Especially in China, Melee. They start to make bigger stones. You can see typical colors of CVD and HPHT at that time. I had my first conference in Mediterranean in 2015 in Greece, and it was about synthetic diamonds, whole conference. So people came from new diamond technology from St. Petersburg with the biggest diamond, and I went to visit their factory. This is toroid press, probably as tall as me, 2 meters, 6'6", I can say. And this is a cubic press. Basically, I think the design was done many years ago in Utah by Tracy Hall, who made first static diamonds by belt, but he made cubic, and Chinese modify it and make it much bigger and cheaper. This is one of the biggest stones I've ever seen, colorless. Now they make it bigger, of course. This is a 32-karat crystal. You can see it's quite a complex crystal. It doesn't look like natural, but in this part here, they cut nice 10-karat VS1E diamond. At that time was biggest. Now, I can't believe, 10 years ago, that was the biggest diamond. What happened in 10 years? It's amazing. Now they can grow 30, 40 karat. CVD, they went to 50. I don't know, maybe I missed news last few weeks, maybe 60, 70. They can make 100-karat crystals now, 100-karat crystals in this kind of presses. It's amazing. Or CVD. So what we did immediately, imagine you're in my conference, we go in the back, we put UV light, immediately look at fluorescence, because this is what you can see. On the long UV, almost nothing. On the short UV, something orange and blue, like this. Okay, blue I knew, greenish blue, but what orange is doing there? So I need to study. So I went to the factory, brought 10 biggest stones, and we went to my friend and colleague Mikko Anstrom in Helsinki. His house is a lab. We did whole day long, all instruments possible, standard advanced. In the evening, we went to sauna, have a few beers, and discuss results. Published it within 1 month. It's a magazine. GRS is my, I can say, research partner, or Pink Diamonds. We published it in their magazine, Gem Research, Contribution to Gemmology. And in Rappaport, it's published article on this. This is a summary here. It's still valid. So no pattern under cross-polarized filters. Very simple filters like polariscope. And usually should be strong 1A pattern, multicolor, or tatami natural. The phosphoresce, why orange? We discover why, because they have 637 defect. We're very surprised to see 737 in HPHT diamond. Then I talked to people like Thomas and people, yes, some producers use some kind of silicon-based containers, and then it's contaminated by silicon. Some producers doesn't use. So don't assume if you see 737, it's CVD. It was a big deal 5-10 years ago to separate HPHT, CVD. I did it. I could do it. But my customer doesn't care anymore. I know, Gary, if you notice that the GA doesn't care anymore. They now just put a laboratory-grown diamond, and they even don't say it's treated or not, because cost of the diamond production is so low that nobody will pay extra for your time to do this. Anyway, this is what we found. They found extra boron peaks. We have many things. So we can prove it. No problem. These are synthetic diamonds. Then at this conference, I came Joy Yuan from Solstar. He also making instruments for detection, also growing diamonds. This is, if you're lucky, you can see something like this. Because it has to be a little bit bigger, cotton ball inclusion, then this is not possible in natural like this. It's quite big and like irregular. They're talking about zigzag surface feathers. Also, Sherry Woodring talk about this. I don't use it, but yes, there could be small feathers there. I like more to use cross-polarized filters. When you see a pattern like this, left or right, columnar parallel pattern. In this case, perpendicular to the table. These are not treated stones, CVD. When they treat them, post-treat them, and more explained in the book, Dusan did a very good job in doing experiments to 1,900, 2,000, 2,200. This pattern disappearing and becoming more natural looking. But still, we can say it's very strong, unusual pattern. We can put them aside as suspicious stones. They're not type 1A classic natural diamonds. They're suspicious. This is what we do with standard instruments. With $100 investment, you can do more. It costs $100, this kit of light and cross-polarized filters. I'm selling it all the time. So it's not like a science, but it is. Indication. Same here. When you see, this was 2017, it's a book on fluorescence of diamonds. My colleague George, who we did together a conference for many years, he got 50 stones, half caraters. If you look at on the left, all of them are constantly, very consistently stronger 1 degree than long UV. But long UV is still present. Why this is important? A lot of dealers, I'm not, maybe some of you are here, I'm telling you, don't use just long UV light. Don't buy these cheap keychains in China for $5, $10, $15 and just check fluorescence of diamond. Because you need to check both long UV and short UV. Why? You can check this diamond and look like a weak blue fluorescence. Oh, I'm very happy. My diamond doesn't fluoresce so much. I can sell it. But you have to check on the short UV, and it's stronger than long UV. It's not natural. It's CVD. And if it's a little bit phosphorescing, it's for sure CVD. If you look at the pattern, it's for sure CVD. So you can do a lot of things just with standard instrument. This is my teaching you, not official from big labs, that you can do a lot if you are trained. That's what I do. I train people. So this is now up to date, what's happening last 7-8 years. This has changed a lot, and I remember this, when they announced 800 per carat, everybody said, no, it's not possible, this is so cheap. How the bees can do these things, 800 per carat? At that time, there were more than 1,000, 2,000 per carat. They were trading, I don't know, I forgot exactly, 60% of rep or whatever, 70, but now it's like 98, 99% off. So basically, they opened the factory in Portland, and they're growing diamonds. And in my opinion, this is not only my opinion from people who are in a trade in India, China, that give green light to all these people. If the bees can do it, we can do it. Nothing wrong with that. Basically, more or less make it a legitimate product. So it was happening a lot. This is my Tajin Lu and 5 other people did a book with me on diamonds, and they were nice to give lectures. One have lectures, what's happening in China? Of course, they know more than me. I give them time to talk. Happening a lot. They're making of all kind of colors, different companies. This is just 6 of them, but I'm sure they have 60. Growing diamonds. This is a very important slide. If you can get, from Richard Hughes, you got one message from me. If you get one message from my lecture today, make this picture. You can say fluorescence of diamond and how you can use it in case of to screen them. So this is very important. Diamonds, if they fluoresce blue, but more than half of diamonds do not fluoresce. This is GA statistics. I didn't do this statistic, but they're saying 30-40% fluoresce. If they fluoresce, 90% of them will be blue, if they fluoresce. So if it's strong or this is very strong blue, almost white, this is medium, natural diamond all day long. I teach in the Ramadan 2018 at the Diamond Burst, Los Angeles, New York, Diamond Dealers Club. I tell them, if you have diamond with medium blue fluorescence under long UV light, it's natural diamond. They say, nobody told us this. I'm talking about this for 15 years, but you don't see it in all articles. So point out. Anyway, this is the problem. When you see yellow fluorescence, green, orange, people are scared. I'm sure you are as well. When you see in your, what's something wrong? Is it synthetic? Is it treated? Just check short UV light. If short UV 1 degree, 2 degrees weaker, you know it's natural diamond. Question if it's color origin or not, this is a different story. Yellow color. But if it's colorless diamond, could be this fluorescence. I'll show you later. So this is opposite for HPHT. Non or very weak, in this case non. Okay, they use very nice instruments, so you can see even the structure here. You can see structure cubic. This is your HPHT all day long. This is your CVD. This is more tricky. You see, it looks blue, become yellow, yellow-green. Even if it's same intensity, even if it's both weak, very weak, you can tell that it's a CVD. We have an app, Geometrics make an app. You can make pictures on this instrument, peel inspector or jewel inspector for jewelry, that you can really compare this and make sure it's a little bit stronger or not. So inclusions. I teach inclusions because they have inclusions, but you have to use very good microscope and find them. You can miss them. So this is relatively easy. It's nice, a little rod-like metallic inclusion. This is a nice picture from Sherry. She contributed to my book 2021 as Dushan. Yes, if it's a magnetic close like this, you can use strong magnet, you can attach it. But don't assume if it's not magnetic that is natural. Could be VS, VVS, VS2 diamond. This should be SL1 and lower to pick it up. In this case, you can see it even mounted stones, so no problem there. And CVD more complicated, as I mentioned. Sherry also mentioned these white short feathers. Yeah, okay, but feathers could happen in natural diamonds as well, but maybe this different, more frosty. I like more this, and I have some samples. When you see this kind of, in one plane, amorphous carbon line up, this is interruption of the growth of the cycle, or you see like one faint color graining like this. Not like a natural diamond color graining when you see many of them. You see one band, be suspicious. It's not exactly chart, it's a couple of years ago, but now I can say much more India, definitely. China is still strong, but India maybe much more. But basically, you can say 3/4 of everything happening in China and India. US still strong, but maybe not as strong as a couple of years ago. Why? Because Washington Diamonds went out of business. And Diamond Foundry is still present. I see it in Vancouver, very strong. Lusex from Israel also went out of business, so something's changed in Israel. Why? You will see why at the end, because labor is much cheaper in India and China, and they cannot produce it in Israel, US at that price anymore because they're losing money. So this is the reason, the same reason why they cannot invest money in mining of natural diamonds so much. They're screaming in Canada, my colleagues at UBC. I'll do a lecture next week for the exploration geologists, because they're closing mines and they cannot find new mines because nobody wants to put money into the exploration. It takes $1 million to open the mine because prices went down, as you know, 30–40% on natural. So this is an important slide. Just to show you, I won't talk about each instrument now. I'll take half an hour, but this is part of my workshops. I start to bring as many instruments as possible for different producers. I sell most of them except, of course, GA, and I don't sell Vista, but all of them you can find on my website, or I can refer. I like a lot EXA. I combine with my kit. With these two combination, I can detect almost anything. It's relatively inexpensive. So you also are using J-Mini, and now you will see, who come to my booth, you can see a better model of OG called CODA. I have it in my booth. So this is something to summarize what I told you about detection with the standard instruments. So this is the kit I developed. My idea, one UV lamp, very important because this is natural diamond, and one cross-polarized filters to put on the top of the light, and you can see pattern. This is your 1A diamond, natural, all day long, no problem. 2A more complicated because it's more like a tatami pattern. Could look like a CVD sometimes, so it could fool you. I put here typical case. This is typical CVD, not, but this is your fluorescence. You see a little bit smudgy, a little bit stronger, could be the same, but this is more easier. No pattern under cross-polarized filters, stress-free, medium, and phosphorescing. This is what we do with standard instruments. Becoming complicated, that's why I update my lectures all the time. Every year I put new slides, So this is what's happening now. Because most of them are post-treated, pattern become crossed like this. And I'm not saying the same as this one. This is definitely nice. We call it needle-like tatami pattern. You can see some colors going through, blue and orange. This is nice, really 2A natural diamond. Not always so perfect, but you see this is natural diamond, 2A. Many of these stones are very big, 5, 10, 15 karat. Cullinan diamond, 2A. All the diamonds that I went to India, big diamonds are 2A. So and this is your classic CVD. What's happening could look similar to this with the post-treatment, as I mentioned. This is what worries me and other people. Fluorescence now on CVD looks almost the same. We can argue this is maybe a little bit more yellowish green, but maybe not. Looks very similar. So if it's non-non, it has some color, you need to check it further. If it's natural, it should be also non-non, but completely black. It's never weak. I said never. It's very rare, weak or medium yellow, and to be weak, medium yellow, natural. Then it's suspicious, yellow, green, green, yellow. All these kind of strange colors adding to your pile suspicious stones. So that's why we develop every year, do something new. This is a new booklet, updated from me and Dusan with the Randy Lightfoot. Why? Because Randy likes to use first order red compensator. One filter, I have it in my booth. It's not very expensive, that you basically see these changes much easier. You see here, maybe not so easy to see. Oh, natural diamond. Okay, in this case, we don't need compensator. It's obviously CVD. In this case, I told you how it's complicated. So this based on pattern only. Nobody can tell if it's CVD or HPHT. Looks very natural looking, very not like this, changed because it's, but we're lucky here. Look at this, all this, like a tree of little black spots. This is your amorphous carbon in CVD diamond. So you always look for something. If all drills failed, yes, you have to send to laboratory. I hope you sent to me in Vancouver, but maybe not. You send to another laboratory, it's fine, where you are. Okay, or if you have EXA, this is very easy to use. And what is different between ID100 from GA and EXA? And I really like EXA, because ID100 stops here. Just tell you, refer, pass, refer, pass. I review it in my book. They say maybe 97%, I think it's more, 95%, in my opinion, referring. My clients saying, referring 5, 6, too much from natural diamonds. Because every diamond that does not show entry center, what is our line here, 415, they refer on ID100 and EXA. This is designed like that. Sorry, this is now, these two should be reversed. Pass is here, refer is here, please. I just last moment my designer. So pass is here, refer is here. So pass, and this spectra, this is spectra you see on second level of EXA. You see it When you press button spectra, and you see the spectra. So this is pass, and then spectra. This is refer, and then you see something like this. What is not always there, but when you see nickel lines in this position, definitely HPHT grown, and they will phosphoresce. And CVD more complicated, and this is the stone. I have it actually on the back. You're welcome to see how on fluorescence we can screen it, but this is to prove 100%. I just put fiber optic to these stones on the side. Little peak here, 737, silicon vacancy, CVD. This is how we combine fluorescence, cross-porous pattern, and EXA, what is photoluminescence spectroscopy. Stone has emission of fluorescence to show spectra. Moissanite won't show anything, because moissanite doesn't fluoresce, but luckily we can detect it just with a loop. What's happening now, more often this year, I don't know, happening in US, but in Canada, people selling moissanite as laboratory-grown diamond. Oh my God. And I got a few cases. Now I have more customers for me for education because they have to take my basic program on diamond simulants. This is easy, but this is happening. Though price of lab-grown coming very close to moissanite. This is another instrument that J Mini, that basically you put many stones in one tray. They also have bigger models, and this is how it looks. It will flag for you. It helps you. So it won't flag CZ, but it will flag this CVD on the back for the potential. It will definitely flag HPHT synthetic. And this is natural diamond, but basically when you do fluorescence, you can see this is natural because it's blue here. So you can basically use different screens. I like it. Instead of buying many UV boxes, you have one instrument. You can check short wave fluorescence. They call it photoluminescence. You can check long wave fluorescence. You can check phosphorescence in one instrument, tick, 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 and give you more information. Okay. This is how it looks when you break it down. Basically, the square, put square for you. So on different levels, you can really see this is these diamonds are natural here, and this is HPHT will also phosphoresce. You can see obviously CVD very rare. They phosphoresce very short time. So basically, you can learn a lot by doing different screens. This is the advantage of this instrument compared to just black boxes tell you natural pass, natural pass. At least some gemology is involved but it's designed really for jewelers and non-gemologists, but some gemology, you can read this carefully if you know what you're doing. If you know this is short UV, long UV, phosphorescence, you can analyze data. But they tell you, basically. So this is all the instruments. Actually, this is now OG. I have this instrument. This is a new instrument. I just tested yesterday. I put on Facebook some pictures. I have it. What is nice that it's very clear results. Before, I tested this one, Dia True, in my book. You have like these results, and you match with the side with the bars. It's good, but this is better because it's much easier to use. I found, and it's, I think, $6,200, and I will start to sell on my website as well. This is what we did yesterday with my assistant, William. He's now in my booth. So who wants to see it, please come afterwards, same and other instruments. So basically, this is how it looks. We put stones, 1, 2, 3, whatever. You can see here, blue, blue, natural. This side, kind of more yellow, green, yellow, are CVD. And this is definitely HPHT. They flag it as red. So they choose different colors for different results. So you can kind of match it and don't think too much. Even CZ or CVD sometimes could be gray. So it's kind of a matching colors. Of course, you have to be good in colors. Hopefully you are. And but also you can really check later on different levels. That's why I like it. You can check UV fluorescence. You can check different options. They give you options to check more. Why it's important? This is my case. I published it in Italian magazine, Italian Gemmological Review, with Alberto Scarani and other people there 2 years ago. So comes the ring like this, 405. Not only one laboratory. He called it a laboratory, but basically it's 2 people working there. 3 appraisers, 1 laboratory in Vancouver call it synthetic diamond. Why? Because they saw clouds. They were afraid of clouds. They thought maybe it's flux cloud. Okay. I'm sure they didn't check cross-porous filters, but maybe they did. It's quite difficult to do in mounted stones, I agree. Difficult to say if there's any pattern here. Maybe I see some pattern a little bit, but very difficult to say. Definitely not clear. It's not HPHT. Anyway, this is why I'm disappointed with the jewelers and gemologists. If they check long UV fluorescence and short UV, they can see it's yellowish green, correct? Which one is stronger? That's who is sleeping, who is up. Left or right? Left. Long UV is stronger than short UV. I did this from 2004, 15, 20 years talking about this. If long UV is stronger, it's natural diamond, okay. But because it's green, they're afraid. And, okay, he was smart enough. I'm not against GA product or ID100. He went to the jeweler, actually selling findings. He has ID100, my customer. And what happened, ID100 says refer. So refer, this fluorescence clouds, he calls it synthetic. Problem is that woman, Indian divorcing husband, and wants to get money, to cash. And he was very upset that husband bought a synthetic diamond a couple of years ago. So they found me. Actually, I have to say, my colleague Harold Lindsay was referring me as an expert because he saw something suspicious, because he's a trained appraiser with me and other people. So he sent to me what I did. Yes, also refer here, but this is the difference. ID100 doesn't have this. I see spectra of the stone. Why it's referring? Because there's no entry center. There's a huge band here, exactly around yellowish green, causing this fluorescence. We call it S3 center, and a little bit here, 795. So nickel could happen in natural diamond, causing this yellowish green fluorescence. And hydrogen adding to this yellow color, who knows, whoever study or read article about hydrogen-rich diamond from Australia, they have fluorescence of yellow. So this, and very often when I do this spectra, I'm guessing the infrared spectra. I'm 9 out of 10 times correct. It's my game for me. I'm by myself or with somebody in black box. So a lot of hydrogen type 1A diamond. This is 100% natural diamond. I can go to court. So what I'm going to tell you, not do only one test. Don't do 2 tests. If you can do 3 tests, do 3 tests. If you can do 4 tests, do 4 tests. Because this is a case where the difference is $50,000 in value. Natural, it doesn't matter if it was S7 stone or something. It's not a high quality stone. It was IJ color, but still, it's natural diamond, 4 carat. Anyway, this is my message of instruments. Of course, people ask me, they can make perfect diamond. Yes, they could make D color, flawless, nice diamond, no fluorescence. But still, we can see how they're growing inside their different internal structure. And this is what Thomas did a nice lecture, and on my Branko Gems Academy online, you can get it. So basically, you can check how diamonds are growing. Growth structure, this is HPHT, this is CVD in layers. This, I can say, maybe the last line of defense to combine this and fluorescence spectroscopy. So he has this instrument, and the BS is also good diamond view, but he has in one. You can check fluorescence and spectra in the same. It's not cheap instrument, it may be close to $100,000, but this is what you can do. We can still detect these stones. So let's summarize what I told you. So a little bit what we did and what is happening in first period. They were very easy to detect them. Large inclusion, magnetism, short UV stronger, no problem. Zoning, we did first booklet. Sorry, 1,000 copies, but I did another 1,000 after. So then we had another book, and identification became more complicated. We started to use more cross-polarized filters and spectroscopy. We make another booklet, laboratory grown. Then we had this interim period. A lot of them were post-treated. Pattern starts to resemble. Definitely we need to use more advanced spectroscopy, infrared, photoluminescence, and other techniques. Still valid standard, but it has to be combined. In the last period, not always positive, just fluorescence to use. Fluorescence imaging and advanced spectroscopy with fluorescence spectroscopy is combined. And we did this special book. It's on the back. I basically get 5 best people that I know who knows diamonds from 5 different countries, and me did this book. People told me, no, it won't sell 200 copies, and I sold 1,000, and I did a second edition. It's on the back. So we can do this. So this is my latest visit, just to finish my talk, maybe a few slides more from India. So people still cut natural diamonds, and this company refused to cut CVD. I went to them first, Darmandan. Big factory. Can you imagine to make a lunch for 6,000 employees every day? 1,500 office and 1 cutters is a big project. So I was impressed, and this is how they look. Very big operation. They have all nice equipment to plan the cutting, and so you can see how many stones they can fit here. Very nice facility. What is nice about them, they also support. They make a special division. That's why DRC I like to promote them, because they make from J Mini that I use to up to this big one to 22,000 that designed for the manufacturers of jewelry to do 100 items at the same time to make sure this is natural. I know they're using in Canada, they're using around the world. Very nice people, and I just sold one of these instruments 2 weeks ago in Spain. Immediately they bought it when they see the results. So then I visited one of the biggest CVD factories. That's what they told me. I didn't count. I count one floor. It was around 100 presses. Sorry, not presses. Growers. They're growers. Because there's no pressure in CVD. The atmospheric pressure, but there's some temperature, maybe 800 degrees. Why? Because they have to grow crystals like this. And you can see how they're hot when they're kind of squarish. And this is their information, 70,000 carats per month. I've seen this cluster. For me, it was fun to see these clusters and to hold. And this is how they look. And this is interesting how they market it on their wall. Doesn't matter if it's CVD rough, this is how it looks, really. This is amorphous carbon. If it's HPHT grown or natural, they're saying it's round brilliant at the end. And they call everything CVD diamond, what is wrong. But this is how they, because people start to go, they call it, do you have, in Vancouver at least, they call it lab, they call it CVD. They stop to call it HPHT anymore, because most CVD on the market, because it's relatively cheaper way to grow, and they can grow big diamonds. Then, I agree with Richard Hughes, not to call laboratory grown, when I come to a place like this. If this is a laboratory, not really. Previous one was really fantastic, big building, 4 floors. Yes, it looks like laboratory, clean. That was really entrance to one of the suburbs of Surat when they grow diamonds. So I sneak one of the pictures. This is how they look when you see this. And I see some inclusions here and strain. So this is perpendicular, so they're basically all parallel pattern. And this is interesting for me how they're growing. They can be 20 carat each of these squares. They can cut maybe 10 carat, 8 carat stones. Okay, so this is another, then I have the third place, the cutting factory, very, very advanced in cutting color diamonds, Lemon Technomist. This is Janak Mystery, very nice. I met him many years ago at the GS Symposium with Octonus, Finland people, originally from Moscow. They're really planning very well how to cut diamonds. This is the update for what's happening. I was very impressed when I can see inclusions so detailed, and I can see this. You can see now instruments like they have. They make everything in-house except screws. They make huge instruments, scanners. They can see diamond rough inside. What is it? The tiny pinpoints. They can plan how light is going through. I'm thinking maybe don't get me to my word in a few years, but I'm thinking one day a lot of people ask me to bring them to India, to this place, because it's a really interesting place. They have a nice, huge amphitheater. I'm dreaming maybe, have a conference there, and then we can see how they grow diamonds, cut diamonds. And you will see later they're very advanced in optical performance of diamonds. So very nice. So they do X-ray tomography to measure these little cracks. They use this little technology how to estimate the color. And the trace, basically they can make this shape fancy intense, they can make this shape fancy light, better you can predict many different shapes and results based on super high technology. For fancy color diamonds, it's amazing. They can recut a lot. I was really impressed how they're doing this in this factory. So from them, something interesting. Oops, sorry, this is I'm not good in this. Okay. Should vibrate, but doesn't vibrate. It doesn't. So I guess it doesn't. So should a little bit make a scintillation or brilliance, but somehow I guess we have an issue. So anyway, what they did, they plan. What is nice about CVD diamond? You can cut them in different cuts and create your master sets of different optical performance diamond. This is what they did. I was so impressed. 150 stones of different shapes, fancy, and I know a lot of people talking about cut of fancy color, but they basically make it based on, okay, now it's blinking a little bit. So basically they base it, the race tray, how they go for the stones, and they can really measure each little facet, how it's going, and they really different between brilliance and fire. They're really super, super advanced, and one day, again, I hope it will happen in next year, I'll do a conference in Dubai to do optical performance course. They did a simple version at my conference in 2019 in Cyprus. People very impressed. Gary Holloway came. So this is the people who are top. A lot of labs using their software, their measuring device, not Serene or OG, because they're super nice, high quality. Anyway, so this is how they looks, this little piece of 150 samples. So can you imagine you have in front of you 150 samples of shape. You can play with them and you can test them and see the performance. This is how you learn. Anyway, I was there, and maybe one day I will do this course because it's really amazing. I also want to learn about this because it's at the end, we should go back to natural diamonds and how they perform. CVD, I can tell you one issue with me. Major labs, including GA, doing these reports, and they're putting, of course, all of them are XXX, hard scenario. This, I think, is also misleading, to do this, because each of them is like egg to egg. People are bringing in bags in Vancouver, open up 2, 3 carat, 5 carat stones. They all look the same. So I think we should go back to natural diamonds and really look at them, their qualities and why they're different, and how we can price them based on color clarity, but also on optical performance. Anyway, to finish, put one slide that hopefully you remember me by this. I'm like natural diamonds, and my dream was to go to the Krishna River. It was not easy. Flight to Hyderabad from Surat, 3 hours on a regular road, I can say more or less like a highway, 2 hours on dirty roads like this, where cows and goats coming through, and then 1 hour on motorcycle, because we cannot walk anymore. We had to go. We went to the Krishna River, where some of the famous diamonds came from Golconda area. There are a few areas, but of course, they don't mind there anymore. It was too big river. But I want to come back when the river is smaller. I'm a geologist. I will get my little hammer. I will try to find a diamond. And believe it or not, I found evidence people are still digging. Next to river, I see little holes. They're not allowed to use heavy equipment, but who has good hammer and good shovel, we can go, if you come with me, and find some little diamonds like this. I bought few because for my reference, and of course, the much more in this area, Hope diamond and all these big diamonds, Koh-i-Noor, and this amazing type 2A diamonds or type 2B, very rare stones. Conclusions. Production on melee is increasing, and this is a real problem for us, because who can check each stone? Yes, we can with the fluorescence technique, jewelry inspector I'm using, or EXA or big labs using big machines, probably from the Beers, ASM for testing. But single stones and your appraiser, you need to check by yourself. Fluorescence is a very important tool for that. But good news that any small, I mean, over 10, 15 points, medium size or high, big diamonds will combination of cross-porous filters, fluorescence, magnification, visible infrared photoluminescence, and imaging, we can detect them still without big problems if you study enough. So this is a case to show you how it looks partially. See, blue diamonds, no problem, natural, but many of them don't fluoresce. See, don't fluoresce. Okay, this is probably natural, but could be yellow, you see, but yellow is stronger, so this is natural diamond, yellow. So this is your fluorescence helping you to tell. So this is very important to tell you that this is not just me. I work with all labs around the world except GA and HRD, and IGI didn't do so much, and published 30 papers, so I'm very happy to keep doing things. This is a big poster. You can see it on the back. Good investment, if you want, $70, to get your patterns of natural diamonds, CVD, HPHT, and sometimes overlap. And of course, we promote other instruments, fluorescence and EXA. Very nice photography by Randy Lightfoot. He's not here this week, but anyway, who wants to learn more? I do online gemology, not only me, I do on gemstones with Laura Kiefert. She is following me. We go for 3 continents, Australia, last year Italy, now we'll do in Montana, USA this summer in June. These are people who are talking for my online, very top experts, including Mikko Anstrom and others in the book, even Turquoise. And this is them, the 6 lectures, around 10 hours, and I'm giving out 20% off on this. This is the book I was talking about. This is really, GMA is using it, and a lot of people. And talking about GMA, I become, a little bit brag, I become center for the FGA in not only Canada, all North America. So I hope some of you GGs who wants to upgrade. I was GG 95 to 2000. Then my instructor told me, then Campbell, you want to do more, do FGA. I did it. Give you a different perspective. It's much stronger in gemstones, in my opinion. GA is still good for diamonds, but gemstones, I think FGA. And we teach my wife, Elena. Now 3 weeks intense, end of April, May. This is what we do in Vancouver, and this is a big thing. Some of you are here who are speakers. I have a nice lineup of speakers. You can see on the right. Everything on the website. You can get my card. But what is big for me, I hope for you, it's 3 mine tours to the sapphire mines. Yogo, very difficult to get. I was there in December first time. I went down to the 300 feet dike, amazing. So the Missouri River with the Bob Kane as a guide, and Potetate Mine, Rock Creek with Warren Boyd, And of course, who wants to see Yellowstone Park, we'll do one day a little bit walking, fishing, looking at the animals. Workshops, turquoise, diamonds, me, half day, and whole day on safaris, doing country of origin. Very unique workshop. I think nobody's doing it in America, but maybe I'm wrong. And a lot of speakers, and please come. And these are people who helped me. And with the slides, people from India, but also Dushan, John Chapman doing instruments, Alexis Zorakani give me some samples and CGL stuff. So thank you very much for coming. And any questions, don't go to lunch straight. You can come at the back and I can show you some stones.
Questions?
Yes, interesting. No, we did not observe that. I know, probably not also, that did HPHT treatment of sapphires. You know this, yeah? Exposed to high pressure, high temperature sapphires to change color. This is debate between labs, GA1 and Goblin and GRS, and if it's affecting the durability. I know you probably think it does affect. I don't know. I didn't study sapphires, but for diamonds that are grown, a natural diamond, they're exposed to 1,200, 1,300 degrees anyway to grow or to bring. So they're making temperatures higher, so 2,000. But I didn't see any evidence that there are less quality or any cracks. Of course, we did experiments where when you start with a diamond SA1 or lower, you'll break your diamond exposing to high temperature, high pressure. Did it happen to me? I did some rough from Brazil looking for type 1AB, and you break the whole stone, but we improve the color. So to answer that, I don't see I didn't see any evidence of less quality or any problems with the durability.
Just one quick observation. When some of the cutters are cutting each material versus natural material, they can hear the difference in the sound and the feel.
Yeah. People who are I can tell you something. I talked to cutters in India. I was also in Israel visiting natural diamond cutters who cut big diamonds 2018. They are telling me they can see the difference between natural and synthetic diamond by the way how they cut. This is their experience. But they won't tell me the secret. What is the difference? Right. You know? And they're telling it's possible to see the difference. But who is cutting? Yeah. They behave a little bit different. There are lots of stories that people tell, oh, CVD looks a little more hazy, more grayish, more this. Again, I'm more scientist. Of course, it's important to observe the stone, but I think it's difficult to tell based on color or based on dust. They're all VVS, VS, and high colors. The D2F now, most of them.
Yes?
It's an Indian company there. It's one of them. There are many of them.
Yeah. And you said they cut with synthetics, CVD, and natural ones, and I said them all as synthetics. Did I understand that correct? Because one sentence on one.
Yeah. No, I just put you. They have on the wall the way how they're selling their diamonds. For me, it was wrong. I just told you the wrong way to sell it. They put picture of natural diamond rough, HPHT grown rough, and CVD rough. At the end, they put a round, brilliant diamond, what is true. All of them end up to be round, brilliant. They call it all CVD diamond. What is wrong? Yeah, they're wrong. It's the wrong way to do it. Definitely should be. What is interesting, in this Surat, they have who knows how many factories to grow diamond. They have 30 presses just to process, to heat treat diamond to CVD from India, and Russians are involved as well in technology because they are very good in technology in Russia. They still how to make these presses to change color of diamond. I was in a factory in Holland by LTC that I've seen. They're just doing that. They're processing diamond for the trade CVD. So it's amazing. I mean.